today I want to talk about the role of designer in helping everyone to access and understand data, but also talking about the relationships between designers, technologists, people working in data science and machine learning, and how it's really important for us all to work together to help solve some of these problems. But I actually want to start just thinking about our relationship with data as general data citizens. And it's not something we always do a huge amount of, but recently we can't help have avoided the impact of GDPR coming in. So the General Data Protection Regulation, our inboxes have been completely and utterly full of, we've updated our privacy policy. And how many people really enjoyed ignoring a lot of those emails? Pretty much every hand. It's been like some bizarre breakup with people we didn't even know we had relationships with. It's been very revealing, the number of people who actually had our data that we didn't really know about. And there's even somebody put together a GDPR playlist on Spotify, which includes all sorts of songs like "What's Your Name? What's Your Number?" but also things like call me maybe, no, don't call me, and 5 different songs called Don't Go. But GDPR is actually, really important to us, and it's a good thing for us. It's about us having more control on where our data is and who's using it. And it's been a bizarre period with coming in. And to most people, it's only been sort of relevant in the last few weeks. But there's been people working on this for a really long time. And now Europe has been seen as a sort of gold standard for the rest of the world on how we look at data protection. And so the last few months, I was giving a talk maybe in March, beginning of March. And I was talking to people then about, and I mentioned GDPR, and a lot of the audience had never heard of it. And also talking about data privacy, and it wasn't a big concern at the time. Now, straight after that talk, I actually went on a trip to northern Sweden, and it was a fairly remote area with no electricity, no water, and so I was actually offline for 8 days. So Pete Traynor this morning talked about being offline for a day, but it's kind of great, just being disconnected. But as soon as I turned my phone back on, I arrived back to this, and suddenly everybody was talking about data privacy, and there was just suddenly a lot of people who'd never thought about it before were suddenly beginning to realize what was happening to their data and how it was being used. And these aren't the only companies involved in this. And it's suddenly become a much more important thing to be people much more aware of it. And I think that's a kind of important thing for all of us to be really think about, is this relationship we have to our data. So we're at a conference today about redefining tech, and we're looking at how the relationship has changed from sort of tech being in a box to tech being mobile to now where we're actually got all these different connected devices around us, and our data is all being connected between them and where it's going. And this, for us working in tech, it's something we're very well aware of, but for everyday citizens, it can be slightly worrying what's happening with all the different data that we have. And when we think about our data, do we think of it as something precious, as something valuable? This study looked at this idea of precious data, and they actually even measured people's nose tip temperatures, and apparently we feel fear in our noses about losing our data. But in this study, what they found was interesting was people do feel their data is very precious, and yet they agreed to sell it off for quite low values. So how we balance what the value of our data is pretty tricky for most people. And we're dealing now with far more huge interconnected systems, that there's so much data flying around. It's really hard for anybody really to get a concept. It can seem quite scary to a lot of people. What is happening in this world of big data and everything flying around us? And we have fabulous data now. What's happening in the world? We can track all sorts of things. We can see sort of glaciers receding. We can see sea levels rising. We have all this data, yet we don't always seem to be solving the problems that it's giving us. And, people do have this dystopian view of where technology is going. 1968 was when Stanley Kubrick and Arthur C. Clarke wrote 2001: A Space Odyssey. So it's not a new idea that we're heading into dystopia. And so for a lot of people, it's quite hard to separate what is fact from fiction. But I'm not sure we're quite there yet. There's still a little way to go. And because there's this. So I don't doubt that there's probably image recognition software out there that is now good enough to differentiate what is happening here. What I love about this always makes me laugh, and I'm not sure there's yet a machine can actually work out why we think this is funny. If anybody is doing a study on the relative humor of animal versus food stuff comparisons, you can let me know. But I think we're still a little way left where we have some things that we're still good at. So today we've been talking very much about digital citizens so far, but today I want to really look at the role of designer in maybe helping to alleviate some of that slight fear and the unknown of what is happening with your data. And there's one thing that designers are really, really good at, and that is around telling stories, how we get information from the data we have and actually communicating it well, communicating our work that we do. But in order to tell the stories, we need to be able to find it from the data. In order to do that, we need to understand the data. And anybody who works in sort of UX design is used to doing research. We're not doing UX unless we're doing some research. So there's all sorts of methods that we would use, both qualitative and quantitative, in how we use this for informed decision making. But I'm not going to talk about this too much today. What I actually want to talk about is that sort of chasm between designers and this huge complex systems that we have. And I feel it. I've worked in design for many years in different tech companies, but I do feel that sometimes there's a bit of a gap there. So what I want to see is, who can help us fill that gap? And certainly one role is the idea of a data scientist. I think it's important for us maybe to learn a little bit more about what they do, and so they can help us fill in some of those gaps. And I'm sure I can hear some of you groan, sort of going, okay, we've already been told that we should learn how to code, and we've already been told we need to know how to write, and we need to know what business is. When do we actually get to do some design? But bear with me, and I hope I'll help to explain why I think it's important for us to know more about what's happening with data. So, I am not a data scientist. I worked as a designer. A few years ago, I joined a mobile marketing analytics company. And I was going in to set up a design team, but I sat next to two data scientists. I didn't have any direct projects with them, but I thought I might just pick up what they do by listening in. So I heard just some snippets of their conversation, and I tried into my head to sort of piece together what it might mean. So these are the things the guys would talk about. Models. They talked about models quite a lot. All sorts of different weird and wonderful models. And then they talked about this rigorous process they went through of selecting the right models for the job. And then there was lots of preparation, there was cleaning and massaging and noise all over the place, and this was all about preparing the models. Fitting was very important, finding the right curves, underfitting, but you definitely don't want overfitting. And I got a bit puzzled what all this meant. Then lots of training. Very important to be training your data because you don't want it to fall over when it gets to the real world. And then it got a bit weird, and they started talking about all sorts of emotional things like regret and regression. And I, in my head, was trying to piece this all together into some kind of story, because I love storytelling, and connect all the sort of pattern that I could see with coming out of what they were talking about. And I got pretty lost, to be honest. My frame of reference was sort of TV shows, movies from the 2000s with Ben Stiller making goofy faces. I kind of accepted I was pretty lost as to what they were talking about. So I decided I don't really know what these things mean. I'm going to actually go and learn this myself. So I decided I was going to learn a little bit of a new language to me. And, sometimes that can feel a bit daunting. But I think it's really important for designers to be quite multilingual. And we already are, in some way, the translator between the user needs and the business goals we have. But it's also really key that we can speak the language of technology and talk to the development teams. But I also think it's really important now that we need to understand a little bit of the language of machine learning and algorithms and models. And it's not about fluency, it's just about knowing enough that we can join the conversations. Because it's really key that we all do have these conversations. And that's why a conference like this is brilliant, because it actually brings together designer and developer tracks and all types of technologists, and we have plenty of time to actually stop and have conversations between people. So I'll repeat, I'm not a data scientist, but I'm going to give you a very quick overview of what I learned. And there may be some people in this room who are data experts, and it may be brave or foolish of me to attempt this, but I hope, like somebody learning a new language, we allow some nuances of how we pronounce and maybe make some grammar errors. I hope you'll forgive me if I've oversimplified things, but I think it's useful for designers to start learning just some words of a new language. So, data science. It varies a little bit maybe from what we know about just about business analysis. It's more about maybe predicting the future. And so I'm using it as a very generalized term. There's obviously all sorts of roles, people who work with data, and it's a very multidisciplinary area, so lots of different people working together. But for the sake of having a label, it's a bit like UX. We have lots of different types of roles, but it's useful that people can identify who we are under a sort of group title. So what I found was that data science is as much an art as a science. There's a lot of nuance, there's a lot of massaging, different levers. There's not so many hard and fast rules to it. So, it's a complex subject. It takes a long time to actually learn. So, it's the same as people going, you're not just going to become a designer overnight. You're definitely not going to become a data scientist. And if I simplify it down to what I learned is kind of three main things, though. Data science around maths, coding, and narrative. I'm going to come back to narrative. But I'm going to start with a lot of the maths, maybe the data scientists deal with around statistical learning. So, very simple example for anyone here. Amsterdam. You all know what Amsterdam's famous for? Obviously shopping for diamonds. So, let's take an example. I need to find a 1.35 carat diamond. So what I might do is just go into a shop, look around, the different carats, the different rings that are there, and the prices for each of them. Now, I don't have an exact 1.35 carat diamond there, but I have a fairly good spread of data. It's complete, and it's fairly well distributed set. So what I can do is actually just take that and plot that in a scatter plot. So then what I can try and do is just try and find if there's a relationship between that. And there seems to be a reasonable sort of linear enough relationship between that. And then I can check where I think a 1.35 carat diamond might fit on that line. And it comes to about 9,000. And there's obviously lots of points that don't exactly fit on that line. So I can kind of pick the majority and see areas I think I might have confidence around my decision. And I can see that there's a fairly good confidence that that diamond will be between 7,000 and 11,000 euros. Now what I've actually done here is, build a model with some data. And this is a type of linear regression model. It's massively simplified, but it's just helpful for designers to understand what the concept is. Now, in the real world, data scientists are going to be using hugely massive data sets in doing linear regression models. And there's also going to be lots and lots of variables they're going to be looking at. But these are the general principles of what statistical learning is all about. And this is where fitting comes in. So, if you draw too simple a line through your data plots, and don't pay enough attention to all the different spread of the points, it's called underfitting. If you try and fit in far too much, it's called overfitting. And a lot of what then data scientists will spend their time doing is trying to find that just right relationship between the data that they have. And I'm going to jump very quickly into a little bit of machine learning as well. Because again, there's lots of terminology and it can be quite foreign to people, but this is what I learned about machine learning. So imagine we have a black box, and what we want to do is get that black box, we're going to get it to learn something. So we can give it some example inputs and some example outputs. And the task is then to see what is the rule of function of what's happening between your inputs and your outputs. So this is where training of your data comes in. So we're going to train this model, see what function it finds. So this is called supervised type of machine learning, and that can fit into two types. Classification. Essentially the question being asked is this A or B? Or regression, which is how much or how many. Now unsupervised, we have example inputs going in, but here's where it's looking for patterns. So this might be where we're looking at clustering, things like image recognition comes in here. And what we can do here is break things down into much smaller tasks so they all build together to answer a bigger question. And that's where people might talk about deep learning or neural networks, because it's similar to how our brains work. But the area that's sort of interesting for designers is around generative machine learning, because this is where it's taking those patterns and producing something new. And often you hear about this in areas like in music, so sort of people taking the music of Chopin and producing new pieces. And you'll hear stories of people accusing Spotify, for example, of generating music themselves rather than paying artists. But personally, I'm a designer. I'm quite interested in art. And one project I found really interesting, it's from a while back, but there was a project to take all the work of Rembrandt and use lots of different types of machine learning on it to actually analyze the whole collection and produce a new painting. But it wasn't just a digital painting. What they actually did is they actually analyzed all the brushstrokes and produced this sort of 3D painted version in the brushstrokes and put it up in a museum. And it was very interesting because people came and were a bit miffed, by it. It was like, okay, was this Rembrandt? Is this art? That famous question. And I was at the Copernicus Museum on Sunday, and there was a little sketching sort of exhibit there. You could take a photo and it would just sketch the sort of outlines of your face. And it was kind of nice, but it wasn't really art to me. But it reminded me of exhibit I was at before in Dublin. And it was in a place called the Science Gallery. And it was called Three Robots Called Paul. And what you had to actually do was sit in the gallery, and 3 robots were essentially arms built into old school desks. And one arm was a sort of camera, which would sort of look at you and then look down at the painting. And the other arm was actually doing sketching with a biro and a piece of paper. It was kind of disconcerting. You had to sit there for 15 odd minutes, even longer. And each of the 3 robots would kind of sketch you. And these are the results that came out. Now, the first robot was a little bit lazy, and it took a long time, and it sort of did a reasonable sketch, but nothing amazing. The second robot was just angry. It was just like this on the piece of paper, and it was really weird because you were looking at it upside down. You couldn't really see what they were doing until you saw the paper at the end. But yeah, that's pretty much a horror show. But the third robot, I got a bit freaked out by this, to be honest. It seemed to have captured something of me in a very weird, sketchy way. And to me, it was pretty close, to what I would consider to be an artist's impression of me. So, but back to machine learning. So, what can be really interesting then is where you combine the supervised and unsupervised learning together. So you might have a data set of which only certain things are labeled. And if you think about it, at some point in your life you learned, someone told you what a chair was, and you learnt what a chair was. For the rest of your life, you've been pretty much good at recognizing what's a chair. And it's exactly like that. So the third type, machine learning then, is reinforcement. And this is all about rewards and punishment. And these are kind of lab rat experiments. So whether you electrocute or give them cheese, that's essentially what reinforcement learning is about. So it kind of boils down to, in a very fast nutshell of machine learning, it's very much about what questions you want answered. So is this A or B? Is it how much or how many? How is this organized? Can you make me something like this? And what should I do now? So I'm jumping into a lot of concepts here at a very high level, but I think it's kind of interesting just to look at the different things the data scientists actually spend their time doing. So there's a lot around predictive analytics. And, you know, the future isn't a certainty. So this is where probabilities come in. And there's lots of maths and equations that we'll use around probabilities, and you'll probably hear about that too. There's also decision theory and game theory. And a lot of this is around a lot about behavioral psychology. It's very close to what UX deals with. It's just that a lot of these things are being quantified in mathematical equations. So, for example, regret. We feel much more regret if we miss a train by 1 minute than if we miss it by 4 minutes. So there's lots of kind of nuance in here. And it's very useful then in dealing with things like if people are working with insurance or buying stock or buying houses, etc. That this is where a lot of this will come in. And important for us just to know what are the types of areas that data scientists are working with. So that was a really fast just jump in to a bunch of different terminologies that I didn't know that I kind of learned. And a lot of these seemed scary enough concepts, but just by taking a few short steps, you can start to begin to understand a little more. And you don't, as I say, have any fluency at all, but at least it means you can have some conversations with people. So I think it's important to understand the data enough. But I want to talk about storytelling a little bit and how that is important for designers. So I also want to talk a little bit about, we've talked about a lot about what data science can give you in helping to understand data, but what can you bring to data science? And, you know, visualization comes to mind, obviously, but there's a lot designers do really around narrative, structuring information, communication and education is really important when you're dealing with something like GDPR. It's part of the stipulation that, you know, the information needs to be clear and understandable. And we have to make those options that people have very clear on whether you're opting in or opting out. But there's also the whole areas of ethnography and psychology and human behavior. And it's important that those relationships are there between designers and people who are working with the data. So I'm going to jump a little bit into talking about storytelling. So when I talk about storytelling, I'm not talking about works of fiction. I'm talking about using the methods of storytelling to make what you're presenting engaging, to make it relevant, to help it stick with people so it's identifiable to them. So this doesn't have to be a really complex thing. It can be as simple as how you use color on a map. That helps to really tell a story. The people identify it very, very quickly as they're going through. But I'm going to try and jump into a couple of sort of live examples because I think, you know, stories should be live. Okay, can we see that? All right, I will speed it up a little bit. Okay, so this is a day in the life of 1,000 people. It's 5 a.m. in the morning, and everyone's asleep. They're all waking up now, and they're all heading off, a lot going to work, and all the people in the middle are traveling. And I think it's a really nice example of simple storytelling. There's lots of different ways this data could have been presented. It could have been some bar charts. It could have been different things. but I think it gives that essence of the busy lives of people, just in the way it's been sort of explained and explored in this. And yeah, I love just seeing, you know, people are heading off to doing leisure. It's sort of the middle of the day. I don't know why they aren't all working. Some people are sleeping in the middle of the day. And you kind of begin to see some stories appearing as this goes through. The day continues on, and sooner or later, everyone heads off back to sleep again. I'm going to jump into another example. So this is a really lovely example because it's very relevant to what I was talking about today about introducing machine learning. So this example here is looking at this concept of working out whether a home is in San Francisco or New York. And start with some intuition. New York is quite flat. San Francisco has lots of hills. So if the house is on a hill, reasonable likelihood that it might be San Francisco. But then we start getting into understanding a little bit more about how you can then start to think about dimensions of that, how you could put those on a scatter plot, and look at where there are sort of boundaries between the data. And now we get into a little bit about training the data sets. And all the different dimensions that we could look at with that data related to the different types of, you know, things around the housing. And now we start looking sort of how you make decisions from that data. And it iterates around a lot of these models, and it starts to build out a tree. This is the bit I really like. So this is where we're starting to sort of train model with some data. So our training data comes through, 100% accurate. Now, reality, we're going to try and put some test data through and see what happens. So again, we can put our data through our model and see what happens. And yes, the errors are due to overfitting, because now I know everything about overfitting. But what I kind of really like about this is it brings together a lot of things. It's an engaging way of presenting what is quite a complex subject. It's really nicely builds up your knowledge as you're going through. And you can kind of play around with this story. It's quite interactive as you're going through. You can see the different paths. And this is what I mean by storytelling. I think this is where it's really important for people who work with data, developers, designers, all work together and think about how can we tell the stories from this data. But the last area I really want to just talk about is around just the ideas of maybe when we're looking at this data, what we need to really be thinking about. So we all have biases. Some of them are conscious and some of them are unconscious. But we need them to be able to survive. This is this superb diagram, I don't know if people have seen it before, of all the different cognitive biases that we all have. And sometimes it's just, there's too much information. We can't possibly handle it all. Sometimes it's just a case of, you know, what should we remember? We can't remember everything. Sometimes it's just we have to act fast and we have to make assumptions. And sometimes we have to try and fill in the gaps because we don't have all the data. What's kind of interesting then is when we take that though and we apply that into something like machine learning, that it can escalate things quite quickly. And we need to kind of be aware of some of these biases ourselves when we're dealing with problem solving that we're doing and we're dealing with producing data. So my example at the beginning may seem a bit silly, where I talked about models. But it kind of helps to illustrate the issue. So what I had was very incomplete data. I was only hearing little snippets of conversation. It was noisy, it was across the office, but I had a completely wrong frame of reference to it. I didn't have the right knowledge to actually piece together what the pattern in that data was. So what I was producing kind of at the end was pretty much rubbish. And that's really key, I think, in actually helping people to understand when we're talking about the biases that we have and how sometimes those can escalate quite quickly. So, you know, there's a bias called the Malkovich bias from the movie Being John Malkovich. And it's this tendency for people to believe that others use technology the same way you do. So if you're, for example, your company, your early adopters are all in Silicon Valley, and that's your existing data set and your frame of reference, that's not necessarily going to be a great model to predict what's going to happen when you try and bring that product to the rest of the world. So I think it's very important, A, to have a diversity input when you're dealing with trying to think about how your product's actually going to help people across different regions and different types of industries. But it's also just important for us to really start to think about how we can all get involved in maybe asking the right questions. So maybe you can just, someone gives you a data set or some results they produced, just be able to ask, where was the data? Where did it come from? You know, was it complete? Was it clean? Do we know anything about the group of people? Is it representative of our users? Questions like that, I think, are really useful for us all to kind of start to have more conversations about. And I do still think it's really important just to get out and talk to people. We may have huge amounts of data set, but it may not be representative of who we want to talk to. And I still think there's a huge value in designers having both qualitative and quantitative data. So actually just getting out, talking to people, finding the right answers, I think bringing that sort of diversity input in along with everything we're learning from massive amounts of complex systems we have, it's still very much, to me, a very key, important thing that we need to look at. So I hope, to any designers in the room, I hope you've seen that maybe taking a few steps might make some of these complex systems a little bit more accessible, a little bit more approachable. And I hope to anybody in the room who actually works in data, I hope you begin to see how designers can actually maybe interact and help you in communicating what it is that you do. Because I do think it is very important for all of us to actually think about how we help digital citizens in accessing and understanding information. Because there are concerns about data protection and data privacy and how we all actually manage to interact with the amount of data we have in the world. So that is it. Thanks for listening, and dzięki.